Hi guys, today we're going to be talking about a new type of data display, box and whisker plots. And this data display is often referred to as box plots. The I can statements we're going to be dealing with in this lesson are: I can create dot plots, histograms, and box plots from data, and I can find and interpret measures of center and measures of variation. For this lesson, we're going to focus on creating box plots and finding and interpreting measures of variation. Let's begin by reviewing measures of center and comparing them to measures of variation. Remember, measures of central tendency describe the middle or average of a data set. Now, to begin discussing measures of variation, we first need to define variability. And variability describes how spread out the data is or how it is distributed. So measures of variation are measures that describe how spread out or scattered a set of data might be. We're going to be discussing two measures of variation in this unit. Those are the range, which many of you are very familiar with, and the mean absolute deviation, which we will be discussing later on in this unit. Let's talk about variability or distribution on a dot plot. Dot plots are great because they give us a visual representation of the distribution or shape of the data. Let's look at three different distributions we could have on a dot plot. The first is uniform distribution. And in a uniform distribution, all the data points have an approximately equal frequency. So if I'm looking at the dot plot, all of the columns should be about the same height. In a symmetric distribution, a vertical line can be drawn down the center of the dot plot. And the result is a graph that is divided into two parts that are very close to being symmetrical or mirror images of each other. A skewed distribution is when the data is not uniform or symmetric in any way. In the skewed distribution, the data might be skewed to the right or to the left, and that means that most of the data will fall to the right or to the left of the dot plot. And in this case, the data is skewed to the right because most of the data, or a large portion of the data, is on the right-hand side of the dot plot. Now it's your turn. Let's look at the data table below. It shows the number of miles run by members of two track teams during one day. You're going to use dot plots to determine the type of distribution. Remember, the distributions are uniform, symmetric, or skewed. Once you've determined the type of distribution for each team, you're going to explain what that distribution might tell us about each team. Here are your dot plots. Team A, Team B. Examine these dot plots, and in the work section of your WSQ, explain what the distribution is for Team A and what that might tell us about Team A, and what the distribution is for Team B and what that tells us. You can pause the video if you need to, but don't forget to hit play when you're done because we have a little bit more to talk about. Now let's talk about box plots. Creating box plots are very easy. You only need to know how to do two things. First, you need to be able to find the median of a set of data. And second, you need to be able to plot points on a number line. Let's first talk about quartiles. Quartiles divide a data set into 4 equal parts. When I create quartiles, since there are 4 equal parts, I'm going to have a first, quartile, which starts at the lower extreme, or my smallest data item, and goes to the first quarter of the data. A second quartile, which will be the median of my data. A third quartile, which will be the median of the second half of my data, or separate the data at the 3/4 point. If I take the third quartile and subtract the first quartile, that will give me the range for the middle half of the data. As we go through this lesson, think about why we might want to know what the middle half of the data is. This is something you may want to write in the summary of your WSQ. But let's get back to this problem. The table summarizes a veterinarian's records for kitten litters born in a given year. If I wanted to find the quartiles of this data, I would first need to line up the data from least to greatest and find the median. In this case, the median is 4. And we know the median cuts the data in half. So let's look at the lower half and then the upper half. Okay? Since the range is affected by outliers, we sometimes need to use another measure to describe the data. Quartiles are one of those measures we can use. They divide the data into 4 equal parts. So let's find the quartiles. Once I've found the median, I'm going to look at the lower half of the data. With just the lower half of the data, you're going to find the median of that half. Then you look at the upper half of the data and find the median of the upper half. The median of the lower half is our first quartile. The median of the upper half is our third quartile. And the median of the entire data set is also referred to as the second quartile. Let's find the first and third quartiles for this data set. Before I can begin finding the quartiles, I must first order the values from least to greatest. If I look at the lower half of the data and find the median of that, in this case there are 2 middle numbers for the lower half. So just like finding the median of a set of data with an even number of data items, I need to add the 2 middle numbers and then divide by 2 to get my first quartile. I'm going to do the same thing to find the third quartile. I look at the upper half of the data and find the median of just the upper half. Now it's your turn. Find the first and third quartiles for the data sets in numbers 2 and 3. Put the work and your answers in the work section of your WSQ. You can pause the video, but don't forget to start it again when you're done with questions 2 and 3. Now let's talk about box and whisker plots. A box and whisker plot shows the distribution of data. The middle half of the data is represented by a box with a vertical line at the median. The first line of the data is the first quartile. So you would plot the first quartile, then plot the median, then plot the third quartile. The lower fourth of the data and the upper fourth of the data represent the whiskers that extend to the smallest value and the largest value, which are also referred to as the minimum or maximum, or the lower extreme and the upper extreme. So making a box plot from data is not that difficult. Let's use the given data to make a box and whisker plot. There are 3 steps to making a box plot. Step 1, order the data and find the smallest value, the first quartile, the median, the third quartile, and the largest value. So I put the numbers in order, find the smallest and largest value, which are simply the first and last data item in my list. I find the first quartile, which is the median of the lower half of the data. Then I find the third quartile, which is the median of the upper half of the data. And I have to also find the median of the data. Step 2, I draw a number line and plot a point above each value from step 1. Now, a couple of things that students often get wrong when creating a box and whisker plot is not listing all of the numbers on the number line, whether they are part of the box and whisker plot or not. The point of a box plot is to show us the distribution. So we want to see where the data might be skewed or where it might be more concentrated. So notice my number line starts at 12 and goes in equal increments or on a scale by 2s up to 28. Even though 12 and 28 are not data points in my set, I still might list those numbers just so I can have a good spread on my number line. Then I plot the smallest value, the largest value, my quartiles and median above the line. Step 3 is to draw a box around your quartiles with a line through the median and whiskers that extend from your first and third quartile to the lower or upper extreme. Now it's your turn. Use the given data to make a box and whisker plot. Let's recall the steps. Step 1, order the data and find the smallest value, first quartile, median, third quartile, and largest value. Then, draw a number line and plot a point above each value. Once you've done that, you can draw the box and whiskers. We are done with this lesson. Pause the video so you can finish question 4 in the work section of your WSQ. Don't forget to write your summary and a question that you or someone else in the class might have about any of the information in this video. You can go back and watch any portion of this video or the entire video as many times as you need to.